Hello everyone, so today we would like to present to you our group project STIAK 1124 Data Structures and Algorithm Analysis from Group D. I would like to introduce you our group members Lizzie Ling, Korja Eun, Paul Hui Lin, Ines Umaira binti Ismail, Jasmine binti Muhammad Nadri. My name is Ines Umaira binti Ismail and my metric number is 306359. So I want to present you agency list manual testing of breadth-first search and depth-first search for Appendix A. Appendix A for agency list, number 1 has been connected with 2, 3, 4, 5 and others has been listed. For BFS, the process of traversal has been shown and also the traversal order has been listed out in the slide. For DFS, the traversal process has been shown and the traversal order has been listed out.
My name is Korja Eun. So now I will show the Appendix B. For the adjacency list, node 1 is connected to node 2 and 3. And for the rest node, it has listed out. For BFS traversal, the process of traversal is shown and the traversal order has listed out in the slide. For depth first search, the process of traversal and the traversal order has listed out in the slide. So now we continue to Appendix C, the adjacency list. For nodes 1, it connected to 2, 4, 5, 6, and 7, and the rest node has listed out. For BFS, the process of traversal and the traversal order has listed out. And for the depth first search, the process of traversal and the traversal order has listed out.
Hi, my name is Lee Ziling, matrix number 30385. So today I'm going to present a chord of breadth search and depth search. So in the breadth search, we implement 5 data structure and 4 methods. So the first data structure is map integer list integer graph, which will store the graph as an adjacency list. The second one is set integer visitor, which will track visitor node to prevent cycle. Third, list integer traversal order, record the order of visitor node. Fourth, integer h count, we will count h for analysis, and the fourth one, set integer o node, which ensure a disconnected node are all traversals. So for the method, we have h integer u integer v, which will add an undirected h and increment h count. Second one, BFT integer start node, we will perform BFS using a queue. Third one, display result long duration, which will show traversal order, node count, h count, and execution time. And the last one is our main method, where we handle user input and initial traversal. So the rest of our code. And here we'll continue to our depth search. So in the depth search, the data structure implementation is same as the breadth search. What the only difference is in the method, we are using the DFT recursive integer node. We will perform recursive DFS. So that's all for our code.
Hello, my name is Jasmine binti Muhammad Nadri, metric number 306408. I will present the output and the analysis. So for Appendix A, this is the output. For BFS, the node visitor is 20. Number of edges 98. This is the traversal order. The time is 1420800. And for the DFS, the node visitor is 20. Number of edges 98. This is the traversal order. And the time is 505 So this is the analysis of Appendix A. Appendix A shows that both BFS and DFS is visited to the nodes and travel 98 edges. And DFS is faster than BFS. Thus, DFS is the most suitable algorithm for Appendix A. And this is the output for Appendix B. BFS is 30, nodes visited. Number of edges is 80. Traversal order, the time is 107,400. And for DFS, the node visited is 30. Number of edges is 80. This is the traversal order. And the time is 256,800. And this is the analysis for Appendix B. BFS and DFS visited 30 nodes and travels 80 edges. And DFS is faster than BFS. So for this graph traversal, DFS is the most suitable algorithm.
Hi, my name is Paul Heding and my matrix number is 305371. Now I will move on to the output and analysis of Appendix C. Here is the table with the result for BFS and DFS. And next is the analysis of the result. Let's look at the table. We can see that BFS and DFS visit the same number of nodes and edges. This is 29 nodes and 37 edges. The next column is the traversal order for BFS and DFS. And the last column is the execution time in nanoseconds. We can see that the execution time for DFS is less than the execution time for BSS. In this case, DFS is about 4.5 times faster. Therefore, we can conclude that DFS is a better choice than BFS and for Appendix C. That's all from our group. Thank you.